Hi there, welcome to Study with Rishi, and this is 10 Minute System Design course. In this video, we will talk about load balancing or load balancers. Load balancer, or as we call it, LB, is a very critical component of any distributed system. It helps to distribute the overall incoming traffic across a cluster of servers. LB also keep track of status of all the resources, all the servers while distributing requests. If a server is not available, then load balancer will stop sending more requests to such a server. Typically, a load balancer sits between client and server, accepting incoming traffic and distributing the traffic across multiple backend servers using various algorithms. By balancing application requests across multiple servers, a load balancer reduces individual server load, and prevents any one application server from becoming a single point of failure, which in some of the cases can then be catastrophic to the overall infrastructure. Now let's talk about places where we can put load balancer. There are three places where we can put load balancer. The first is between user and the web server. Then second is between web server and internal platform layer. The internal platform layer then can be like application server or cache server. And third is between internal platform layer to the databases. When we use load balancer, users will experience faster uninterrupted service, and service providers experience less downtime and higher throughput and more availability. But how load balancers choose where to send the next request? Well, first they will try to ensure that the server they are talking to, they are choosing, is actually responding appropriately to the request. That means the servers are alive, and then they use a pre-configured algorithm to select one of the servers from a set of healthy servers. Now, to find out whether a server is alive or not, LB will do a health check. LB will send a ping to the server and will observe the response from the server. If a server fails to respond back for some defined number of times, it is considered failing the health check and taken as dead. Then it is automatically removed from the pool of available servers, and the traffic is not forwarded to it until it responds back to the health checks again. Second part is algorithms, the pre-configured algorithms. So there are a number of algorithms we can choose to configure LB2. There are example least connection method, least response time, round robin, weighted round robin, or IP hash. Now we can choose any of them out of these algorithms, so we can create our own algorithms also. One more question which should come to our mind is that now LB is being the single point of failure within a distributed system. To overcome this, a second load balancer can then be connected to the first load balancer so that they form a cluster, and then each of them monitors each other. Because they are equally capable to serve the traffic and the failure detection, in the event of failure, main load balancer will be replaced by the second load balancer. Yeah. So this is the video about load balancers. If you like the video, please consider liking it and subscribing to the channel. I am also a mentor at Scalar Academy, and if you have a question around it, I have given my details in the description of the video. Do consider sending me a ping there. In the end, thank you for your time. Thank you for watching the video, and I hope you liked it. Thank you.